the participants and our today's morning faculty, Sri UK Guru Vittal sir. He is head of the department in Geotechnical Division of Central Road Research Institute. Uh, all of you know that we are conducting this 6 days online mode of this training program of use of waste material in highway construction. Today is the fourth day of this ongoing training program. In last 3 days, we have covered the use of fly ash in embankment construction as well as in structural concrete and PQC. Yesterday, we discussed on use of waste plastic. So today in the morning session, we will discuss of use of C&D waste. Uh, in addition to that, I also want to inform all the participants that the lecture which we have proposed on Saturday, that is on use of Slack, due to non-availability of our faculty, due to his some engagement or some meeting in the Ministry of Road Transport and Highway. So that lecture we have already shifted from Saturday to today afternoon. So therefore, today there will be two sessions. One is in the morning and other one is the afternoon. The morning session, all of you know that is organized during 10 o'clock to 1 p.m. and afternoon session today that will be covered during 2 o'clock to 5 o'clock in the afternoon. For the afternoon session, we will also share a separate web link uh, for the online participation of the participant. So all the participants are requested that for joining the afternoon session, uh, all are requested to use that separate link that we have already shared in your email ID. We also share that link also in our WhatsApp group also. So morning link will not be effective for the afternoon session of today. Okay. Uh, Another thing is that accordingly, tomorrow will be our the last day of this training program. So tomorrow in the afternoon we will conclude our this training program after completion of the tomorrow's lecture, that is on recycle payment. So on Saturday there will be no class. We have already shifted Saturday class uh, into today afternoon class. Okay. So during this 3 hour session of forenoon session, there will also be a 15 minutes time break at around 11:15 to 11:30. I will again request to the participant that please make it a two-way communication. Please ask your question. Please clear your doubts during the presentation of our faculty, sir. However, there will also be a question answer session also at the end of the presentation. However, during the presentation also, participant can also ask their questions with the permission of the faculty, sir. So I will not take much more time. I request Sri Guru Vittal sir to start his presentation as well as his experience on the subject. Thank you.
Thank you, Gupta sir. I think I am audible.
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. Uh, Welcome to all the participants to this training program on use of waste materials. So I will be making a presentation with regard to use of. I'll also be briefly covering the use of locally available materials also towards the end, because CND waste is also a kind of a locally available material. So this present
Visible, sir.
Yeah. Now I think it is in full screen mode. Okay,
Sir, full screen, sir.
thank you. So actually, I retired from CSIR CRR on 31st August this year, few days back. So that's why I have written former chief scientist. Thank you. Now, coming to the outline of my lecture, I'll be discussing about the statutory guidelines because use of waste materials. There are many waste types of waste materials which can be used for road construction. You are learning in this training program. But apart from this fly ash and CND waste, no other waste material is having a kind of a statutory requirement. That is a requirement from the point of view of government rules and regulations, etc. For fly ash, they had issued this gazette notification very long back, almost 20 years back. Since that time, they have revised it also. How much percentage of fly ash is to be used, up to what kilometer distance it is to be used. All those things are there in that fly ash gazette notification. Gazette notification. In a similar manner, notified for CND waste also statutory. The gazette notification is there, and this gazette notification, of course, it does not say with regard to how many kilometers we have to use from the part of generation. It tells about the population of cities and in which city what type of a system is to be adopted. Like that, that I will be discussing with you. Next point will be with regard to the use of CND waste in roadworks. What are the different advantages and disadvantages or limitations? Technologies for building demolition. If you want to get good quality CND waste, you must adopt very good practices for demolition. So those issues, what type of different demolition techniques are available to engineers. So that I will be discussing. Then CND waste material characteristics, that is the physical properties, chemical properties, and engineering properties of this CND waste will be presented, and how these properties can be useful for our road works. That will be discussed. Guidelines for construction methods for use in road works, including cement concrete. The Indian Roads Congress has come up with a CND waste guidelines. So the highlights of that guidelines, what it contains, and how to use this material in the roadworks. So those issues will be covered. Quality management, when we use this CND waste, what type of quality control tests we have to do, how to ensure that whatever the road we have constructed using CND waste is of very good quality. So those issues will be covered. Then some case studies I will be discussing, and then, as I told in towards the end, some other industrial waste, etc., which are not being covered in this presentations. So that I will be discussing. Now coming to the first point, importance of using waste and locally available marginal materials, including CND waste. Of course, there are these two terms are there. One is waste material, and another is a locally available or the marginal material. Waste material we normally refer to the industrial waste. There are agricultural waste also, like rice as cash is there. That also has been tried as a sutki, as a lime replacement material. But of course, the quantum of generation is not so much as compared to the industrial waste materials. So CND is also an industrial waste material because construction is also in industry. So we many times we say construction industry, road construction industry. So that is also an industry. So the waste material produced by any industry, the reject material produced by any industry, that is called the waste material. And locally available, of course, it mainly refers to the materials which don't have very acceptable properties with regard to road construction. So and that's the difference between waste and locally available material. But not many a times we use it as synonyms. and many a times both will be same also. But like for example, this laterite is there, or a slate stone is there. Laterite is it is available in plenty in coastal areas. So this is a softer type of material. So that material, that is a softer type of aggregate material. Like slate. Slate is not very soft, so the slate is very hard stone. But the problem with slate is that it comes in layers. So its flakiness index will be very high. So those things are considered as locally available or marginal materials, which are naturally available. But waste is definitely it is a byproduct or the reject material of an industry. So C&D is also a waste material. Now, what is C&D? Waste generated during construction, renovation, or demolition of buildings or structures or associated activities for infrastructure provision. So, any infrastructure, maybe a building infrastructure or maybe a road infrastructure, when we construct it, during construction also, some amount of waste material will be produced. Like for example, we are doing concreting work, we will not be very much 100% sure exactly how much, of course, the quantities we can calculate, but little bit of plus and minus percentages will be there. And because of that, some amount of concrete at the end of the day may become excess. So that of course, when it becomes excess, we throw it out at another place. So that becomes a C&D waste, construction and demolition. So during construction also some waste is produced, and during demolition also some waste is produced. So that is why the term construction and demolition waste. During demolition means when we demolish a old building, when we are doing a renovation, remodeling of an old building, then also the waste material is produced. Like for example, uh, we want to increase the size of a room. So then what we do, we join together two different rooms. So in between, if a thin wall is there, we demolish that wall and we make the room bigger. That's a very simple thing. So when we demolish that wall, whatever the waste that is generated is a C&D waste. So and when we demolish an entire building, then also the material, huge quantities of waste will be produced. So that is also C&D waste. So C&D waste is the material generated during construction, renovation, or demolition of buildings or structures. I have used the word structures also because, like for example, if you demolish a bridge, then also whatever the waste that is generated is called C&D waste. You need not C&D waste is not uh, limited only to buildings, even the structures also. When you demolish an industrial structure, like let us say a chimney is there, that chimney if we demolish, the whatever the material that is produced, that is also C&D waste. It comprises of chunks of concrete, brick walls, tiles, stone pieces, mortar, plaster of Paris, etc. So what are the different components of the C&D waste are given there. The different components of C&D waste are nothing but whatever the components we had used during the construction. So that is the concrete, bricks, etc. Bricks, of course, we have constructed walls using the bricks. So the brick wall, chunks of brick wall, tiles for flooring, tiles on the wall, stone pieces which are there in the concrete, which are there in the plain concrete as well as reinforced concrete, mortar for plastering, plaster of Paris for false ceiling like that, etc. If we have used. So all these materials combined together is referred to as C&D waste. And there are other materials which are also generated during the demolition process. They comprise of materials like wood, steel, sanitary fittings, pipes, conduits, light sheet metals, etc. And definitely all these materials, they have a recycling value, reuse value. So when you might have observed that when we demolish a building, the first thing the contractor will do is that he will remove all these wooden fixtures, windows, doors, whatever the wooden fixtures are there. So all those fixtures he will remove it carefully, and then he sells it back, resells. So that has got a very good value. Wood is a very costly material, so it can be very easily recycled also. So that's why it is to be, I have written, should be separated and removed because it has got a resale value. Then steel can arise from the reinforced cement concrete, and steel can arise from whatever the fixtures are there in the buildings, etc. Also, so that is also, that can also be easily recycled. So that's why during the demolition also, they first they demolish the concrete. They maybe by using labor or by mechanized methods. And during when they demolish the concrete, they take away the whatever the reinforcement steel or maximum percentage whatever they can take away, that they remove it. Sanitary fittings, pipes, conduits, light sheet metal for roofing, etc. Light sheet metal we may have used. So all these can be easily separated, can be separated, and they are removed for reuse. Utilization key, debris should not be intermixed with excavated or other waste, crushing and saving to bring the material to proper gradation. So everyone would have seen the C&D waste heaps because we are all civil engineers, so we would be associated with so many building works also, not only road works, building works also we would have been associated. And in all those, in many locations, many sites, this demolition works will also be there. And what type of waste material that is generated is very well known to us. So this mainly it will be comprising of the debris or the chunks of the demolished building, and most of the times you can observe that will be heterogeneous. Whatever that is demolished, they just dump it. And unfortunately, along with that, they mix the excavated earth also. They mix excavated earth, whatever that some reject material, waste material is there. All those materials they are dumped in one place because they want to transport it to the landfill area, all the waste material. So that is not the correct process. That is not the correct process if we want to make use of C&D waste. That is the most important point I want to tell you. So that's why I have written it as utilization key. Key for utilizing this C&D waste. So we should separate out the C&D waste material which can be recycled, and that should not be intermixed with soil and other waste material. If the soil is excavated, soil is there, that itself can be used as a backfill material. Soil can be used as a very good construction material for the embankments. So that's why we should not unnecessarily spoil the soil by mixing the C&D waste with that. And if we mix C&D waste with the soil, both will become useless. The soil will have particles more than 75 mm dia. So the more than 75 mm dia particles, they are not usually used in earthworks because the maximum particle size, the MORTA specification says is 75 mm, 200 mm, 50 mm layer thickness is there. So one third of that should be the maximum size, so around 75 mm. So that's why. But C&D waste chunks you would have seen it will be half a meter, even 1 meter thick chunks will be there. So if you mix it with soil, definitely neither the soil will be useful nor the C&D waste will be useful. So that's why the key for the using of this C&D waste, that the debris should not be intermixed with excavated earth or other waste materials, crushing and sieving to bring the material to proper gradation. That is the second step. Once we keep these materials, the generated material, waste materials separately, C&D waste, excavated earth, steel, etc. So then we can definitely use each one of them in a different manner. This CNT waste, I already told you that can be used as a backfill material. The CNT waste, we would have to crush it and sieve it to bring it to the proper gradation. So thus, we all know CNT waste will be having very big chunks. So that chunks as such are not useful for any road work. So that we just like this rock pieces are there. So how do we use the rock pieces? Whatever the rock boulders are there, the boulders are crushed and sealed to make them into aggregates, and then we use the aggregates in either bituminous mixers or reinforced cement concrete mixers, cement concrete mixers, or maybe even in GSB also we can use that. So in the same manner, CND waste is also to be crushed and it has to be sealed to bring the material to the proper gradation. Now, what is the quantum of generation that is there? So many different estimates are there. At least for fly ash, right now we have very good estimates of how much of fly ash is produced, and other steel slag and copper slag and other type of industrial waste also, because those they are generated by specific industries. So that's why if we ask the industries, they will be able to give the data. They are able to give the data, and that data is collated, it is collected and collated and summarized, and we can calculate what is the total generation of fly ash or steel slag or whatever type of other industrial waste is there countrywide, that we can calculate. But unfortunately, uh, construction industry is very spread out. It is spread out all over the area. And who is demolishing his building today and who will demolish tomorrow, that is not sure. Municipal authorities will be knowing, but exactly they also don't know, and they also don't have the exact data regarding the CND waste. So that is the problem with our CND waste, and countrywide, how much of this CND waste is generated, we don't have, only estimates are there. Now, this 500 to 300 kg per square meter after demolishing Pakka and semi-Pakka building that I have written it, that is for a particular location, any building, any particular building we are demolishing. So in that, we can calculate the area of that building. So per square meter, this is the amount. And if you are remodeling and for the Pakka building, very good type of building construction. And if we are doing the construction, during construction also, of course, as I told you, little amount of CND waste will be generated. This is the quantity, 40 to 60 kg per square meter during construction. But this much, 500 to 300, that will be generated immediately during or immediately after demolition. So it will be ready for use. But this 40 to 60 kg, that is entire construction period considering entire construction period. So entire construction period may be few months or even a year or more than a year. So this quantity, so that's why it's negligible if we calculate month wise. But of course, CND waste is one of the largest waste streams. You would have seen landfill sites. Most of our landfill sites in the municipal areas, majority, of course, will almost 30, 40, 50% will be CND waste. And household waste and organic waste will be other part. Okay, so that's why our landfill sites are getting filled up very quickly because of the CND waste. And the next important point is that compared to the densities of the other municipal solid waste and this other components of municipal solid waste and CND waste, this is very heavy. So that's why even transporting it is also very cumbersome, very difficult task for the municipal authorities. Now, how much per year all over India that is generated? There are different estimates. One estimate I have written here, I don't know. In Delhi, around 3 to 4,000 tons per day is generated. That's what they calculated. Okay. Managing CND waste, you can refer to the CPCB and other guidelines. So they will give this approximate estimates of C&D waste. Managing C&D waste scarcity of landfill site in many of the countries. Actually, unfortunately, in our country, not only C&D waste, using any waste material in road works or in any building works is not immediately accepted. As soon as you suggest to use fly ash, use slag, or use C&D waste, the PIO or the concerned engineer will say, what is this? How did we construct it? How our road will be of good quality? Why you are forcing us to use this kind of a material like that? So this kind of questions will arise. This is very unfortunate, actually. Otherwise, if we look at worldwide, even the advanced countries also, in the advanced countries of Europe and America like that, there it is already an established practice to use this kind of byproduct. They don't call it as a waste material at all. They call it as a byproduct material, industrial byproduct material. So this Europe also, we can consider the European countries as world leaders for using this kind of waste or byproduct materials, and including C&D waste. Using C&D waste for aggregate manufacturing is an effective step for management and its utilization. Now, some terminology, this I will be using in my lecture. First is a natural mineral aggregate. So natural mineral aggregate, coarse aggregate particles retained on 4.75 mmC derived from crushing gravel or hard stone, meeting the property requirements of IS 383. So whatever the aggregate particles, whatever the coarse mineral particles we derive by crushing a rock piece or a gravel or hard stones, so that if it is more than 4.75 mm, we call it as coarse aggregate. If it is less than 4.75 mm size, we call it as sand or fine aggregate. Okay, up to 75 micron, it's fine aggregate. Below 75 micron, of course, it becomes silt and clay. So 75 micron to 4.75 mm is the sand size particle or the fine aggregate particle. More than 4.75 mm is the aggregate particle. Up to 75 mm, we call it as aggregate, and we use it in different ways. Of course, normally for concreting works like that and all, we about 20 mm size, and like that we make use of. Bigger size also we can use it in mass concreting, and maybe in WBM, and maybe in WMM, and this GSB material. Bigger size particles also we use. So that is the natural mineral aggregate, NMA. The important point is that it must be derived from freshly crushed, naturally available stones, naturally available rocks, freshly crushed. Yeah, that means it must have not have been used even once. Now, what is the recycled aggregate or processed C&D waste? The material generated through crushing and sieving to yield a mixture of stone aggregates, brick bats, mortar bits, tile pieces, etc., having a particular size range, passing and retained sieve size. Recycled aggregate is made from C&D waste, has a higher water absorption. So this when C&D waste, the key for using the C&D waste, I already told you, crushing and sieving is required. We should not intermix it with the soil, and then we should crush it and sieve it. So when we crush and sieve this C&D waste particles, whatever that is resulting aggregate is called processed C&D waste, and that actual term that the IS code uses, IS 383 uses, is the recycled aggregate. So please see that the recycled aggregate is having a mixture of stone aggregates, brick bats, mortar pieces, tile pieces. All these are the recycled aggregate is made from C&D based, it has higher water absorption, lower specific gravity. Now, there is one more term that is called recycled concrete aggregate. Now, previously I told you with regard to recycled aggregate, and now I am telling you with regard to recycled concrete aggregate. So, what is that recycled concrete aggregate? It is the crushed and size graded concrete material made from discarded or demolished concrete, and it is derived from concrete after requisite processing. So, this RA and RCA are different. IS 383 recognizes this thing, and IS 383 says that somewhere they will say you can use RA, somewhere they will say you have to use RCA. So you cannot use RA when RCA has been specified. So what is that RCA? RCA is recycled concrete aggregate. That is, it should be made from exclusively from concrete chunks. Now, whatever the big chunks of C&D waste are there, that we can segregate while demolishing it. So that brick pieces, mortar pieces that we can segregate. And when we are demolishing concrete, we should keep it separately. So this segregation is very important. Segregation is very important even in municipal solid waste also. Municipal solid waste should never be intermixed with this organic matter. So similar manner in the C&D waste processing, we should segregate the concrete pieces, we should segregate the brick and tile pieces, etc. Brick and tile, of course, it can be intermixed, no issue. But concrete pieces, it should be segregated, because if we crush the concrete pieces, we will get the original stone aggregate. We will get original stone aggregate. That is very precious. So we are all very much hard pressed for getting this stone aggregates. It's getting depleted. That's the countrywide problem. So if we get original concrete and get back the original stone aggregate, so that is known as recycled concrete aggregates, RCA. RCA comprises of stone aggregates which were used for preparing the demolished concrete, usually having some amount of mortar, hydrated cement paste sticking to the stone aggregates. That's of course we can expect it. When we crush the concrete, we cannot get the original aggregates in that natural form. That will be some having a coating of this whatever the mortar, cement mortar is there. That will be there. So that we cannot remove it. That if we want, we can remove it, but that will be very costly process. So this usually nobody does that. So that's why, and there is no accepted practice also for that. So that's why we crush the concrete and we prepare the RCA. The RCA will be comprising of stone aggregates having a layer, having a coating of the cement mortar. RA will also be having stone aggregates, because some concrete chunks you just cannot totally remove. So some stone aggregates may be there, and then brick beds from the walls, mortar pieces, tile pieces, etc. So the RA is more heterogeneous. RA is more heterogeneous, whereas RCA is not that much heterogeneous. RCA is not that much heterogeneous. Whether this RCA will have mortar also, you may ask. Definitely, it may have some mortar also. May have some mortar also, but the majority will be stone pieces, because when you crush the concrete, whatever the mortar is there, so that will get powder. That will get powder. So not only crushing is there, the processing involves sieving also. So whatever the powdered mortar is there, that is removed, and only the stone pieces are to be used. The paste reduces the specific gravity, increases the porosity. So whatever the aggregates are there, so above that aggregates, I told you that the mortar paste will be there sticking to that, and because of that mortar paste sticking to the aggregates, the specific gravity of the stone pieces comes down. Mortar pieces are porous, So that's why the specific gravity will come down, increases the porosity. So that's why the RCA material will be having a higher water absorption compared to RCA does not, and it should not contain brick bats, tile pieces, etc. RCA does not contain brick bats, tile pieces, etc. So that is why it is not as much heterogeneous as compared to RA. Then there is one more term, that is a RAP, recycled asphalt pavement. Recycled asphalt pavement. So that is of course it's entirely different. And how do we get the RAP? When we mill do the milling process for this bituminous layer, we get RAP. The milling is excavating the top few centimeters of the bituminous layer to remove whatever the cracks are there like that, etc. So that material, very fine grain material that results from milling, we use a machine, milling machine. So it cuts the top few centimeters. So that wrap is once again recycled along with the bituminous mixes. So there is an MORT specification is there, clause number I have written 519, and then the IS 120 is also there. So they tell us, they give the procedure for reusing the wrap, and that of course I am not covering it here. The wrap is entirely different from C&D waste. Wrap we can use only for bituminous mixes. Wrap of course people have used for making concrete also. People have used it. It's kind of a R&D work. It's not a very well established practice, I believe. So that is why I am not covering it. Now coming to statutory guidelines, what our statutory guidelines says regarding this use of C&D waste. C&D waste management rules 2016 issued by Ministry of Environment, Forest and Climate Change, Government of India wide notification so and so dated March 2016. So I told you with regard to this flash gazette notification. So it was issued way back in 1990s. Then of course the revised versions also have come. This C&D waste guidelines was notified. It is called C&D waste management rules 2016. It was notified in 2016. So the application is waste resulting from construction, remodeling, repair and demolition of any civil structure generating C&D waste. So this guidelines is applicable to all those places where C&D waste is generated. So what does this guideline mainly contains? It tells with regard to this generators, bulk generators, sorry, bulk generators and municipal authorities, what their obligations are there, in what way, what they are supposed to do. Duties of the bulk waste generator. Bulk waste generator means bulk C&D generator more than 20 tons per day. So if you are constructing a small residential building, this is not applicable. Only when buildings are demolished and this much amount of waste is generated per day, this is per building and this is per project. This is per project. So this much amount of waste is generated. So then only it is termed as bulk waste generator. If he is not a bulk waste generator, what he should do? The guidelines says that he must take that C&D waste and deposit in designated C&D collection points. The municipal authorities should designate. These are the C&D collection points. So just like they have designated this household municipal waste collection points, collection vans, etc., collection methodology, etc. Same manner, the municipal authorities have designated locations where C&D waste will be collected, will be received from the generator. So if he is generating less than this, he should take it and give to them, hand over to them. If he is generating more than this quantity, he himself has to do some tasks. So what are those tasks? He should segregate the waste into concrete, soil, bricks, wood, steel, and submit the waste management plan to local authority. deposit waste at a designated collection center and make specified payment for processing of CND waste generated. So this is a very important. So if he's a bulk generator, he must segregate it and of course, what is his plan to use this wood, steel, etc. Like that, soil also is a very precious material. So such material, what is his plan? And then whatever the material that is remaining after that reusing, he should submit it to the designated authorities. And of course, the authorities will charge for collecting his waste material and processing it. So that charge also he has to make the payment. Now, what are the obligations of the local authorities? The local authorities shall get the waste from the collection center, transported for processing, devise measures for management of CND waste, including processing facility, provide incentives for using the material from CND waste such as non-structural concrete, paving blocks, etc., lower layers of the road pavement, colony and rural roads. So the authorities are obliged to make have some methodology for collecting the transporting and processing this CND waste that is collected at the collection center, and then they should set up the plants. They should set up the plants, processing plants, including the processing facility. Written there, and then not only the processing and making reusable articles, they must subsidize. They themselves must use that kind of a products. What are those? Non-structural concrete, paving blocks, and roadworks also. Roadworks is also one of the products that they have specified in the guidelines. That means municipalities who are constructing the roads are obliged to use this CND waste that is generated in that municipality in their roadworks. State pollution control boards to grant authorization to CND waste processing facility, prepare annual reports for compliance. So there are CND waste processing facilities are there in many metropolitan cities. Previously, it was for first time, as I believe, as I know, it was set up in Delhi. It was called Buradi. There's a place called Buradi in Delhi. There this plant was set up. Then seeing how efficiently it is doing that work of CND waste processing, they set up another plant in Shastri Nagar, and now I think there is one more. Third plant is also there, all in Delhi. Ahmedabad it is there. Bombay, Mumbai it is there. So I believe now many other cities also they have set up these CND waste processing plants facilities, and so they have to prepare the annual reports. Also, SPCB, State Pollution Control Boards, they supervise this in what way these plants are working, so that they themselves don't generate pollution. They themselves don't cause the pollution. State government to provide land for setting up the CND waste processing facility. Procurement of materials made from CND waste shall be made mandatory to a certain percentage, say 10 to 20% in the municipal and government contracts. So using the CND waste in those plants, waste processing plants, they can make value added products. So these value added products can be in the form of paving blocks or this curb stones, roadside curb stones like that, non-structural concrete items. So that whatever those plants are producing, at least some percentage of that, 10 to 20% of that products should be purchased by the local authorities. Duties of CPCB, BIS, IRC, and central government. Central Pollution Control Board, of course, they are the main authorities. They are the main body who has to oversee this implementation of these guidelines. Bureau of Indian Standards, they have to issue codes and guidelines for this use of CND waste. So accordingly, IS 383, they have revised now. IS 383 is the guidelines for use of aggregates in concrete works. So that has been revised now. And now it has a provision for using CND waste also. The highlights of that I will be discussing in my presentation. Then the Indian Roads Congress and central government. IRC has to issue the guidelines for using the CND waste in road works. Already that guidelines has been issued. I think 2018, they 2017 or 2018 they have issued. I will see. I will show you that guideline 121 and highlights of that IRC guideline also I am discussing. Central government, of course, they are the overall responsibility for the implementation of this notification. IRC to prepare code of practices and standards for use of recycled materials and products of CND waste specific to construction of roads. So that's what IRC 121 I told. Criteria for site selection of CND waste processing facility. Now we just cannot set up a CND waste processing facility in the middle of a heavily populated locality. It has to be a little bit away because whatever the precautions you may be taking, how much caution you may be exercising, some amount of dust and noise will be there. So we cannot set up that plant in a heavily populated area. We have to set up the CND waste processing facilities away from the a little away from the population area, densely populated areas. Time frames for the cities with different population levels. Actually, 2016 it was notified and they have given by what date the different municipalities with the different population level they must take up this CND waste utilization. Of course, there is already some time lag is there. So many that is understandable. Application formats. The formats for applying if you are a bulk generator, how to apply for permission. If you are a small scale generator, what all the application formats are there. Now CPCB, after that CPCB has issued the guidelines for utilization of the environment guidelines on environment management of construction and demolition waste subsequently. And then in the 2017, 2016, that Gazette notification was there. 2017 CPCB issued separate guidelines. So the Gazette notification is mandatory. This is guidelines. Overall to guide you, anybody, guide any authority how to implement it. Uncertainty regarding some highlights of the guidelines I will be discussing. So uncertainty regarding the quantum of CND waste generation that I already told you in the beginning of this lecture. That is that point has been given there in even here also. Initiative to promote CND waste recycling in India by MOUD, Minister of Urban Development, Minister of Environment, Forest and Climate Change. So all these different bodies are there. There are some statutory bodies and some are wings of the government. So what type of initiatives, what type of measures, what type of steps these people are taking, that is given there. Options for CND waste recycling facility. It can be a mobile plant or a semi-mobile plant or a stationary plant. So depending upon the capacity you want to recycle. So the capacity is defined by whatever the municipality or the city size is there, city population size is there. So if the city population is very high, we would like to have a bigger facility, and that bigger facility will be definitely be a stationary one. But if you are small scale generators are there, and we small scale generators are there, and we can process the site itself, and reuse it in the building in construction or road construction at the site at that site itself. That will also be very good. So for that we have mobile processing plants also. Of course, most of them are imported. As I know, I don't know. I have not come across any Indian manufacturer, but most of them are imported. Definitely, it's time fully in India also the machinery manufacturers, road machinery manufacturing will take up preparing this kind of machines. Environmental impact from the CND waste processing, noise and dust provisions for preventing pollution. So this point also I briefly discussed. So some amount of dust and some amount of noise will be definitely be there in these plants, and what will the maximum limits for such noise and air pollution, that also been given in this guidelines initiative by the urban local bodies. What are those steps taken by the urban local bodies? That's also given there. Now, the lack of options for the dumping of environmental degradation due to C&D waste, lack of options for dumping of C&D waste, misuse of vacant plants, city outskirts, roadside, etc. This we are all very well aware. In what way? Actually, people demolish a building and they will not be knowing where to dump it, because you just cannot dump it in the municipal solid waste MSW dustbins. So what they do? So they fill up the truck. They wait till night is there. So during the night, they just like thieves. They go and they will be looking for where they can dump that C&D waste, and somewhere in the vacant plants. The mostly it will be in the vacant plants. We have not constructed the buildings as yet. It will be filled up with C&D waste. City outskirts, roadside. This is also another very big, very problematic area. You are hearing this urban flooding. Since last few years, we are hearing urban flooding. Urban flooding was there in Mumbai, very large scale, and very unfortunate. It happened few years back. Then urban flooding was there in Chennai, and now the urban flooding has happened in Bangalore. We are all seeing that videos and etc. like that in newspapers like that. Why this urban flooding is happening? One of the biggest reasons for this urban flooding is C&D waste. The C&D waste that has been dumped in the drains, roadside drains. So it is choking those roadside drains, and the flooding is happening. So that's one of the bad effects of side effects of this C&D waste. Dumping in drains and nullas leading to clogging. A reported case of illegally filling up water bodies and wetlands. That's another big issue, especially with regard to Bangalore, I believe. So, as you would have seen in the newspaper reports, Bangalore was having so many tanks and water bodies, and all those water bodies have been filled up. And where do you get so much of earth? We don't get earth very easily. So that's why how they fill up those water bodies, they bring C&D waste and fill up the water bodies, and once the water bodies are filled up, they will spread some soil and make it look like a very good cloth, sell it. Difficulties in transporting and municipal solid waste, degrading MSW means meant for composting and energy recovery. So MSW, which is having organic matter, it is very good. It's very much useful for composting. That is for making the manure, but and also energy recovery. That means we can burn that organic matter in the MSW and we can generate electricity. But if we intermix C&D waste with that MSW, municipal solid waste, definitely the both will be become useless. C&D waste will become useless as a construction material because organic matter is there. MSW will become useless as a composting material or manure material because the C&D waste is there. So this kind of a situation should not be there. So it should not happen. Occupying a landfill meant for MSW, this point of I just told. Now, advantages and limitations of C&D use mitigates the shortage of aggregates available closer to the site, especially within a city where processing plant can be set up, saving transportation cost of the aggregates. This is also very important. Of course, the first point we all very well know, the aggregates are in short supply all over India. We are having a very severe shortage of aggregates, both coarse aggregate as well as fine aggregates. In a city like Bangalore, uh, fine aggregate, that is sand, it is coming from a distance of around 450 kilometers from Trichy. They are bringing sand to Bangalore. That is almost 450 kilometers. It's same everywhere almost. Now, Haryana and the mining. So where they are getting aggregate from? They are getting aggregate from Rajasthan. So that is hundreds of kilometers away. So this situation is there everywhere, all over India. And this situation is all over India. And some states like this, Bihar and Tripura Even with for hundreds of kilometers also you will not get aggregates. For Bihar you have to get aggregates all the way from Jharkhand, and that means you have to cross the river, Ganga river, and bring it. So very long transportation, and that means you will be burning up so much of fuel, so much of CO2 generation, greenhouse gas generation, and next thing is the cost, very high cost. So to mitigate this shortage of aggregate, the best thing is to reuse this C&D waste, and it is available closer to the site. I told you that we can have mobile processing plant, mobile processing plant. Whatever the big chunks are produced, if we want to extract aggregate out of those chunks, we can have a mobile processing plant set up at the site itself. And using that, instead of bringing the aggregate from a very far distance, we will be generating our own aggregates from our own buildings. You, new aggregates from the old buildings. So that's a very good proposition. Conserves natural aggregate resources, saves land required for dumping the C&D waste. This is also a very important point because the landfill sites are now yeah, very much in scarcity. And but only the limitation. What is that limitation? That limitation I have put in a red color. We must be aware of that limitation, and we must plan and design our structure accordingly. The strength properties of the processed C&D waste may be less than natural mineral aggregate. That I will be discussing in the coming slides in what way. Whatever the strength properties are there may be the compressive strength, maybe the impact value, maybe the abrasion value, etc. Those properties of the processed C&D waste aggregates will be little bit lesser, little bit lower when compared to natural mineral aggregates. Well, let's see some slides with regard to using sewage practices in abroad. Closed loop recycling system, German practice to reuse 80% of the C&D waste. So I told you that wherever the building demolition works are there the new buildings are also going to come up. So in those locations in Germany, it's a practice to reuse 80% of the C&D waste that is the site is generating. And it's a closed loop system, closed loop recycling system. Means first you demolish the building, generate C&D waste, you have a mobile processing plant, process that, and you have the resulting aggregate. Once again, you use it for the new building construction. So it is a closed loop. So, and in that they make use of 80% of the C&D waste generated. That means you can imagine how little quantity of fresh material they will be bringing to new construction sites. Up to 95% of the concrete rubble recycled in Japan. Quantity to quality in recycling, scrubbing of RCE. So this is what now they are focusing on. So in Japan, it is a really a wonder. Japan is really a wonderful country. They have so many firsts to their credit, and this is one of their very good innovations. They are using 95% of the whatever concrete rubble they are generating. Normally, we may reuse 1, 2, 3, 4, 5% of whatever the concrete we are uh, demolishing, and we usually throw away the remaining 95, 98% of the material. Very unfortunate. Whereas in Japan, it is reverse. 95% or more, they are reusing it in their works, and they are throwing away hardly some 4 5% material. And even in there also, 95% how they are using. Now they are focusing on improving the quality of recycled concrete aggregate. I told you that recycled concrete aggregate made exclusively from concrete will be having a coating of mortar. Will be having a coating of mortar, natural stone aggregate covered with some mortar. Now in Japan, they are having some systems wherein they will heat the aggregate, and so that the stones separate out from the mortar, and they will scrub it. Scrubbing is also there. Scrubbing process is also there, and remove that water so that the stone pieces, they once again attain whatever their natural strength properties are there. So that is the extent to which the Japanese have gone. It's a widely accepted practice in many countries in Europe and America, like Denmark, USA, UK, France, etc. The international specification, what they say, the European code EN 12620 allows recycled aggregates in concrete, recycled aggregates, processing of inorganic material previously used in construction. RCA can be up to 90% and RA can be up to 50% in concrete. So RCA and RA, they are entirely different terms. I already told you RCA is derived exclusively by crushing concrete. RA is derived by crushing C&D waste. That means RA can be having concrete, RA can be having brick beds, RA can be having tile pieces, etc. So that's why RA will be more heterogeneous, be used up to 50% replacement, whereas RCA can be used up to 90% replacement of natural mineral aggregate as per EN 12620. Even we don't allow that much. What does BS 8500 British code says? RCA and structural concrete having compressive strength up to 50 MPa. Up to 50 MPa concrete we can use RCA. Mortar to be less than 5% in RCA. If the mortar is more, usage is limited to 20%. No limits for the mortar content in RA. Of course, RA we cannot use in very high strength concrete. RA we can use in the mass concreting or concrete having a lower strength. And RCA, the extent of use of RCA is also depends upon the amount of coating. That of course you will have to judge it visually. And if the amount of coating is more, we can use up to 20%. Otherwise, uh, the code DIN 1045, what does it say? It says that up to 25% RCA can be used in this German code. Up to 25% RCA can be used in structural concrete of to strength of 30 MPa in the dry or low humidity condition. So actually, if the concrete can be concrete will be subjected to all different kinds of environmental conditions. If it is in a humid condition, the problem is that the water vapors will enter into concrete and it may lead to the erosion and this corrosion of this reinforcement bars. Of course, water vapors along with that they may carry this salts also, chlorides and sulfates, and that will also affect this concrete properties, skin property, and the corrosion of reinforcement, etc. So that's why the concrete is in low humidity condition. We will be less prone for this corrosion of reinforcement. And in such equations, we can use the RCA to the 25% up to 30 MPa concrete. That's what they say like that. They have specified. Because if you use RCA, then the RCA will be having a higher water absorption capacity. So if it is used in a humid condition, it will absorb more water, and more water means more degradation of the concrete. So that's the idea. Summary of the international specifications, different countries, Britain, United Kingdom, Australia, Ireland, Korea, Germany, Portugal, Hong Kong, etc. So RILAM is not a country, it is an organization. It's an organization of just like Indian Road Congress is there, the RILAM. They also issue the guidelines for the use of road construction materials. Just like PRK is there, permanent association. PRK is there for any road work. So RILAM is with regard to this concreting works. So there are different guidelines. Of course, they differentiate between the RCA and RA. And with regard to RCA and RA, they have different types of specifications. So how much RCA can be used and how much RA can be used and what can be the allowable maximum strength of concrete that up to which we can use. Of course, above 30 MPa or 25 MPa, like that, very few countries only. You can see that our RLM says, okay, up to 15 PM, but that is for us. And the Korea 27 MPa, okay. Korea says that use only RCA. RA they don't allow in uh, concrete. So Korea, Germany, Portugal, Hong Kong, they all specify RCA. But the RA also many places there it has been specified. But as you can see, RA is for lower strength concrete, lean concreting works. Lean concreting and mass concreting works, we can use RA. For higher strength concrete, we should use RC. This is the general thumb rule. For lean concreting or mass concreting works, we can use RA, recycled aggregate, which will be having brick pads, tile pieces, etc., etc. But for higher strength concrete, it is always, we should always use RC. Now, coming to some important points with regard to demolition technologies. What is that demolition? Demolition is destruction, breaking down, dismantling, destroying a structure after its service life by pre-planned and controlled methods. So then this is very important. This is very important. Whenever, whatever the structure we construct, it is having a particular service life, a road pavement is flat top pavement. Usually it will be having a service life of 10 to 15 years. And cement concrete pavement maybe 25, 30 years of service life. In a similar manner, a building also maybe 50 years, 70 years like that, maybe the service life of the building. And of course, there are buildings which are centuries old and still people are using it and still those buildings are in good condition, etc. That's a different aspect. But normally, the building life is considered as about 70 years or a maximum 100 years like that. And after that service life is over, either we have to go for major rehabilitation of that building or we many a times we dismantle, demolish that building and construct a new building. So this demolition, as we already know, it results in CNT based generation. Demolition can be by two methods. One is manual demolition. Manual demolition is widely used technique. It's labor based. Labor use hammer, chisel, pneumatic hammer, jackhammer, etc. And the demolition, it's limited to small structures, small residential buildings. And of course, the manual demolition will be a longer process compared to mechanized methods. And but the advantage is that if you are doing manual demolition, you can easily take out the usable part. Like this windows, doors, fixtures are there, other sanitary fittings are there, tiles are there, so that you can very easily separate out, and even the steel reinforcement also you can very easily separate out during the manual demolition and reuse it. So that is some advantage will be there, but the disadvantage is that it will be a lengthy process and maybe the generation of pollution will also be, the duration of pollution generation will also be longer. Now, for bigger structure, bigger buildings, we normally use this mechanized methods. They are time saving, lower chances of damage to adjacent structures, widely adopted for large structures. So whenever, wherever the apartment blocks are there that are to be demolished, or huge industrial buildings are there, so that are to be demolished, bridge structures are there. So there we adopt this mechanized methods. So what are those mechanized methods? The first and the foremost, very wide, very yes, wrecking ball. So this is that wrecking ball. It's a iron ball, and that is hung from a crane. And when the crane swings, it swings in such a manner that the ball hits the building with a great force. So when it hits the building with a great force, it's just like a hammer, but a very big size hammer. So it hits the building and the building is demolished. ball weighing up to 6 tons suspended from the crane, either dropped or swung into the structure, crushing the building. So this is what it explains. The ball weight can be up to 6 tons. It is suspended from the crane, okay, and it can be either be dropped or it can be swung so that it hits the building and demolishes or crushes the building. The disadvantage is very straight and simple, but the disadvantage is that highly skilled operator is a must because if let us say we are using that ball, it is usually used by swinging. So if you are using that ball, during that swinging, when it goes back, it should not hit other buildings. So and even when it is hitting that intended building also, it must hit with a particular force. That force should not be very high. If it is very high, so much of demolition will take place at once, and then once again damage may be there. So this or it should not be very low, so that the demolition takes a very long time. So neither of them. So that's why the skill of the operator. To what extent the ball should be swung, the only the operator will be knowing. He will make a guesswork and he will do that because of his experience. And other disadvantages are it produces a lot of dust, noise as well as vibrations. Um, and of course, if your building is nearby, even though your building may not be hit by this wrecking ball, definitely you for many days you will be subjected to this dust, noise, and vibrations. So that's why they prefer to operate this kind of a wrecking ball in an open space. A large amount of open space should be there. Like for example, this a few days back, the Supertech towers in Noida, they were demolished, and whatever the towers that were demolished, the next tower was almost adjacent to that demolished tower, just 9 meters away, just 9 meters away. So if you are having just 9 meter distance difference between these two towers, how can you use this wrecking ball? It's impossible. And next is the using the explosives to bring down a structure. We can use dynamite and such type of explosives, and we can blow up a building and blow up a structure and bring it down. But of course, it is a kind of a unpredictable and a dangerous practice. You just will not be knowing anything. We are aware that debris will be flying or to what extent destruction will be there, and so all that problems will be there. All the problems may be there, but sometimes they you do use this kind of a blasting technique. They have used it successfully also, like Mumbai-Pune Expressway. There was one structure called Amrutanjan Bridge, that Mumbai-Pune Expressway. It was a very old bridge, and they wanted to demolish that. So during this, when COVID was having the peaks, so during that time, so much of restrictions were there, and uh, vehicle movement, everything was suspended, and so that was a very good time for them for bringing down that structure, and they used blasting technique, and they brought down that entire bridge structure in one go. So that was very easy for at that time because there was no vehicle or movement, everything was bad. Everything was under lockdown. So that's why they made use of that occasion and brought down. But you don't get that occasion often. Normally, every day, some other traffic, some or other traffic will be there. You have to close that road and then do that, and then of course all of that traffic like that, all such issues are there. Next will be the diamond sawing technique. In diamond sawing, we can use a wire saw or we can use a hand saw. There are different types of saw, wall saw or chainsaw. So we can saw and cut this concrete as well as brick walls. Fast and precise cuts, vibration and dust free, cuts in closed space, underwater operations also. So even for bridge structures, we can use it below the water also. continuous water supply and skilled operator are required. When we are using this saw, of course, water supply is required. So a lot of heat will be generated. Crane for handling the cut pieces will be needed. Whatever the big chunks are there, so that if you that are to be removed, and we need a crane for that. This diamond sawing technique is used for dismantling bridges, road beams, etc. It is very widely, it has been adopted all over India. Diamond sawing and diamond sawing we can use in the smaller enclosed space also. This hand saw will be there, so that also can be used in an enclosed space also. Even that's especially useful for this renovation. Now I think it's 11:15. Shall we take a break?
जी सर.
So 11:15 to 11:30.
Okay, sir.
सर 11:30 में कंटिन्यू
We
सर.
will have a break. Please come back. Please come back, participants at 11:30. We can have a small break for a tea. Thank you.
थैंक यू सर.
Hope you are all there. Now you have come back. So we were discussing about the use of this C&D waste and what are the different demolition methods. So then I will continue with the properties of C&D, the other demolition methods and the properties of C&D waste and in what way this material can be used and the case studies. So let me once again share my presentation. Just a minute.
सर स्क्रीन नॉट विजिबल.
Yeah, I will share my presentation. 1 minute.
विजिबल सर.
Yeah. One more. So we are back to the same slide where we had stopped. Diamond sawing I was discussing. So let us go ahead. So this is that diamond sawing technique using hand sawing. So these are smaller ones. So this is a little bit bigger one, and so you can. They are now sawing off, cutting off the bridge structure like that. So this is a very versatile equipment, but only the problem is that it requires a continuous water supply. Now, the next important technique is implosion. This implosion, now you are all very well aware, everyone in India would be knowing about this implosion because of this, what they did to this Supertech Twin Towers in Noida. Very tall structures were there, and using this implosion technique, they brought down that entire structure within seconds, within 9 seconds. What is that implosion? Implosion is using the explosives to knock down the columns so that the building collapses, joined by the Firm for Controlled Demolition International of USA. So they now the implosion technique and those things also you will be very familiar because it has been widely discussed in the press and TV. And whatever the columns are there, to those columns, the columns are demolished in a systematic manner, in a controlled manner, one by one. And the columns are demolished by tying the explosives, maybe TNT, maybe a dynamite like that. Okay, TNT is the usual one they use. And the sequencing of this blasting is also, they calculate, they decide so that the building itself collapses within itself, within itself. So that is known as implosion. Placement of explosives and sequence of detonation are critical. Building is demolished in a few seconds. Suited for high-rise buildings. Fall and scatter of the debris is controlled. You can see that I already told you that two towers were very nearby, just 9 meters away. The other tower, nothing, absolutely no harm to the other tower, except of course the whatever the dust is there, that will be there. Other than that, no debris. And it can be used for concrete, it can be used for brickworks, everything. It can be used for steel, it can be used for concrete, it can be used for brickworks, everything will be brought down. It's a technology intensive because, as you know, you would have read it, around 20 crores was spent for that demolition itself. And after that, a huge amount of dust cloud was there. But unfortunately, the wind was blowing, and then so the dust has dispersed. Exclusion and safety zones are required, and the careful handling of the explosives. The even the foreign experts was called. So some photograph of the implosion of other buildings. So this also will be very quick there. Not only the Supertech towers, actually it happened earlier also in Cochin. Cochin within that exclusive economic zone, he said very near to sea they had constructed the same similar kind of residential building structures, and they were also demolished in the same manner. So next technique can be a high reach arm, which is ideally suited for demolishing the tall structures, and this high reach arm we can it is got a base machine, that is an excavator fitted with a long arm for demolition with a telescopic boom, and demolition tools can be either a hammer or it can be a crusher or it can be shears like that, and that can be operated in a similar. It is similar to this swinging ball, but the swinging ball, the swing is uncontrolled. But this high reach arm, it is very much under the control of the operator. So since there is no swinging ball, it is comparatively safer method, can reach up to 90 meters. No need for scaffolding. Dust should be controlled by high pressure water spray. No control over falling debris. The debris, it can fall a little bit away also. So that is the problem. And of course, dust nuisance will always be there. So this is that high reach arm.
फोन का चल रहा है, ये वाला नहीं चल रहा है
So,
लैन फोन का तो चल रहा है, देखो एक बार
इस म्यूट कर दीजिए.
ये रहा उसी पे चल रहा है.
म्यूट कर दीजिए. आपका क्वेश्चन है तो आप बॉक्स में लिख दीजिए, कमेंट बॉक्स में, या क्वेश्चन है तो डायरेक्टली क्वेश्चन पे आ जाइए, अदरवाइज म्यूट कर दीजिए. सो दिस high reach arm, you can see in the photographs, and so it is having the base crawler. Then to that they have attached them. Either it can be a hammer type or it can be a shear type, like that. Concrete crushers and bursters can be they operate by applying the pressure. It can be used for small jobs in the narrow inaccessible areas. Cannot cut the steel rods and needs water spraying. Not for tall buildings and low output. And then the hydraulic splitters can also be used for exclusively cutting this concrete. Burster, it's similar to this splitter. Then coming to the pavement breakers and rubbleizer, of course, I already told you with regard to RAP. RAP is exclusively with regard to this asphaltic or the bituminous pavement. But many locations, many places, we have concrete, cement concrete pavement also. Cement concrete has a longer life, 40 years, 50 years life. And after that also, if it is too much under distress, we may not be able to provide a overlay over that, and that has to be demolished. That has to be broken down. So, what type of equipment can be used? So, specialized machineries are there for breaking cement concrete pavement. For bituminous pavement, it is called the milling machine. For the cement concrete pavement, of course, it can be either a falling weight impact breaker or a resonant rubbleizer. These to operate on different principles. So this falling weight impact breaker, as the name itself shows, it operates by dropping the weight, and the resonant stabilizer, it operates by two vibrations or resonance. Drum cutter for cement concrete pavement. Uh, So this is that high impact drum hammer schematic view. This is the resonant repelizer. So it vibrates kind. This is the impact hammer, and this is the resonant repelizer. Normally, I have not seen this kind of equipment in our country, but because in our country the cement concrete pavements are also not very widely there. Only now, because of that 4 laning and 6 laning works, they have constructed a considerable amount of cement concrete pavement, and that also they have not those pavements have not completed their uh, service life. And so these are not very much popular in India, but abroad they use this kind of equipment. Now there is another term called deconstruction that is also gaining importance nowadays. One is of course the demolition is there that we all know, and the deconstruction is also gaining important. What is the deconstruction? Deconstruction specifically focuses on recover, reuse, repurpose, and once again, when we make it for a repurpose, once again we will be reusing, recycling. Instead of reusing it, we can put the word recycling. So deconstruction is systematic disassembly of a building or structure with the purpose of recovering the construction material for reuse in new construction, renovation, or manufacturing into products. See, there are two ways. One is that a big wall is there, you demolish it, make C&D aggregates, this recycled aggregates, REA from that, and use those aggregates. That is one way. Other way is that you don't demolish it, you recover the bricks itself and use the bricks in for constructing a new building. So these two the approaches are different. The methodology is different. First approach is recycling. That means whatever the building that we are deconstructing, it must be having certain residual good strength of. So if it is having, so those bricks and even the wall portions that itself they are trying to reuse. They will cut that wall and the entire chunk of that wall. They keep it. They use it using a maybe using a crane. So the necessity for constructing a portion of a wall in a new building is overcome. That's the idea. So in the same manner, if we deconstruct, we can use the columns, RCC columns, we can use the RCC beams, we can use the RCC slabs. So all such possibilities are being explored, of course, in R&D terms. And a few buildings also abroad, they have tried it, deconstruction. It's an environment-friendly alternative to demolition. When we do demolition, a lot of noise and dust is created. But in deconstruction, the generation of noise may be there. We are dismantling it. A little bit of generation of noise may be there. But at least the dust pollution will be overcome. The deconstruction reduces the waste going to the landfill. It's a sustainable practice, more environment-friendly practice. First step is to prepare a detailed plan of dismantling. You must carry out a building survey to identify the reusable materials. Then we have to plan the protection of adjacent properties, health and safety considerations, and top-down method is usually adopted. Since deconstruction is nothing but reverse of construction. So in construction, what we start with, we start with the foundation and then the plinth. Above the plinth, we build the walls. We will be having we will be installing our doors and windows. And once the walls are ready, brick walls are ready, then we go for roofing, RCC roofing like that and all. And there be other way when we are constructing the brick walls. First of all, we may construct the columns, and in between the columns, we construct the brick walls like that. So that is the process. So when we deconstruct it, it will be reversed. So first of all, we will remove the this roofing, and then we will remove the wall portions, reuse it. We'll remove the column portion, reuse it, keep it for reuse like that. So, but already the RCC columns and RCC beams are there. How we can use it? So that is a challenge. That's a R&D aspect that the designer has to solve it. So this kind of a beam is there. It's capable of carrying this much of weight, of course, based on original drawings and like that, and his experience also he can calculate. And that kind of a beam structure or a column structure, where he will use it, how he will use it, all these things he will have to work on. So the easiest is the reclamation of non-structural components like this decorative elements, flooring, tiles, etc. are there. So they can be very easily reclaimed and recycled. So that is called soft stripping. So deconstruction is a you can say is an advanced type of demolition process. Now let us go to this C&D waste material characterization. So what exactly the different components of C&D waste are there? Physically, different agencies in our country, they have carried out various studies and they have come up with their own conclusions. As per TIFAC, Technology Information Forecasting and Assessment Council, so in 2001 they did a study and they said that the C&D waste is composed of so many other matter and their relative percentages, approximate percentages is like this. You see that the masonry or the mortar is the maximum and the concrete is also considerable. And of course, wood and metals, they are in negligible amounts. Normally we remove that, but in negligible amounts. We normally remove that. But unfortunate part is that soil is almost 1/3 of that, and so that's why it makes the entire C&D useless. In 2004, the MCD study was there, and then also similar thing, but then they noted that soil component is almost even more. IL and FS, they did in the study in 2005. And there also it is almost 1/3, and 60% will be the masonry and concrete. So if we add up these two, that result will be more than 90%. So the major component, 1/3 will be soil, C&D waste, 1/3 will be soil, and 2/3 will be this brick and cement, concrete, cement, cement, water, etc. Another, but 8 to 10% will be the other materials, so like maybe the tile pieces and maybe the asbestos and maybe the sheet metal and such material. So we have to be careful to avoid this 1/3. We have to be careful to avoid this one. If we avoid this 1/3, this 2/3 will become very useful. So this is a photograph of how the C&D waste dumping site it looks like, the material looks like. As I already told, there will be a big chunks as well as smaller sized pieces also intermixed. It's a heterogeneous material, and of course, size of the chunks you have no control because whatever the demolition process is there that decides the size of the chunks. If we use a mechanized demolition, the chunks may be larger. If we use a manual demolition, chunks may be smaller. The first and the foremost thing for using this CND waste, this type of CND waste, will be that we should ensure that this 1/3 of the soil and gravel is not intermixed with this material. And once we have ensured that we are having only the CND waste, that is the brick and concrete portion, then we have to crush it and sieve it and separate it into different size aggregate portions. So this is what we have done. So in CRRI, we collected the CND waste from Delhi CND waste dumping yards. We took it to the aggregate crushing plant. Same, it's not any specialized crushing plant, aggregate crushing plant and aggregate sieving plant. We crushed it and we have separated it into 3 different components. One is that the CND waste aggregates. So this, you all know, is RA, recycled aggregate. This is not RCA, because if it is, this is having the, you can see this is having brick pieces, this is having tile pieces, etc. So this is not RCA. Stone aggregates are also there, but the brick pieces are also there. So this is RA. And of course, the size of this aggregate is between 20 mm to 6.3 mm. After this material was crushed and sieved, these were the 3 components which resulted. So this was around 42%, and this was around 30-30. So this is a very small size aggregate. We can call it as Jira size aggregate, 6.3 mm nominal size, around 130 or 1/3 of that, and another 1/3 of that was got powdered. It got powdered during crushing. So how is that powder looking like? So we can see that. So all the 3, they were used for different works, types of material, in different types of road work materials. And those details, what are the properties of these 3 components, etc., that I will be discussing. Chemical composition of that CND waste, loss on ignition, it's not very high, negligible, around 3.5%. That means whatever the CND waste we had collected, it was not contaminated with organic matter, because the loss on ignition in CND waste is mainly because of the organic matter. That means municipal solid waste was not intermixed. Whatever the organic matter in the building, like this wooden doors and windows are there, they are removed. They are removed before demolition, so that they can be reused. So that's why the organic matter was lesser. Silica was more natural. All our construction materials, they have a high percentage of silica. So CND waste is also having a high percentage of silica. Next is alumina, about 6%. And other materials like iron oxide, calcium oxide, etc., they are in there. And calcium oxide, you can see it's around 4.34%. So that's why the pH value is also very high, 9.7. Normally, you know that cement concrete is an alkaline material. The alkalinity of cement concrete ensures that the corrosion of a reinforcement doesn't happen. So alkalinity of the cement concrete occurs because of the lime or the calcium oxide, calcium hydroxide in the cement concrete, which is generated during this cement hydration process. So similar manner in CND waste also, that that material will be carried, which was originally there in cement concrete. So that's why here also it's a very much alkaline material, 9.76 pH. Alkaline material, 9.76 pH. Construction and demolition waste, CND waste properties. Specific gravity marginally lower due to porous brick beds. Powdered CND waste it is, we can classify it as a SW material. It's non-plastic, high phi value, cohesion is almost zero, high CBR value, moisture density test curve, that is the Proctor compaction test curve, is flat, similar to sandy soils, and is having a good permeability. Powdered CNT waste, I mean this one, this particular material, less than 4.75 mm size, which was almost one third after crushing. So this was almost when we did this stream analysis and LLPI test, we classified it. It was non-plastic. It was classified as a SW material, having a very high phi value. I will show you the strength properties table. And C was zero, cohesion almost zero, high CBR value, etc. Now coming to this CNT waste aggregates, that means these two components, this one and this one. Water absorption is higher than the limiting value. The limiting value for water absorption for the natural mineral aggregate is around 2% usually. And this CNT waste is having a higher water absorption. That is essentially because the brick beds are there, mortar pieces are there. Brick beds and mortar pieces, they are porous. They will absorb water. So that's why CNT waste aggregate will also be having higher water absorption. Whatever the natural aggregates are there, if it is having a higher water absorption, it will be unsound also. That is a soundness test. It's a chemical test. MgSO4 and magnesium sulfate and calcium sulfate are used. And as a in that soundness test, if you use a porous type of natural aggregate, it may fail in the soundness test. Soundness is nothing but a accelerated weathering test. So during the weathering process, what happens? The water will enter into the aggregate if the aggregate is porous, and if that water is acidic, then it will degrade that aggregate particle. It will break up that aggregate particle. The water will be acidic because of acid rain, and natural rain is also little bit acidic in water, acidic in nature. So that's why we conduct the soundness test. It's a kind of a accelerated weathering test. But this brick bed, whatever the CNT waste aggregates are there, they satisfy the soundness test. That's a good point. Strength properties of CNT aggregates marginally lower than the hard stone aggregate. Strength properties in terms maybe impact value, maybe crushing strength, maybe abrasion strength. It's a little bit lower. So, I mean, compared to natural mineral aggregate, and lesser than the specification limits. Strength properties depend on the composition of CNT waste. Actually, if you see this material, it's I already told you many times that it is heterogeneous. So it is having stone pieces, it is having some mortar pieces, it is having brick beds, it is having tile pieces. So that is why the strength property will depend upon the composition. How many brick beds are there? How much of stone aggregates are there? Stone aggregates quantity is very high, and brick beds quantity is very less. Definitely, its strength property will also be more. But if the brick beds are more in number, strength property will come down. Porous aggregates need more amount of bitumen. Bitumen coating is not satisfactory, even with the emulsion also. So when we tested in by using in a bituminous mix, this was the this is what happened. The aggregates which are porous, they absorb some bitumen. So that's why normally if you are using about 5.4, 5.5% of bitumen in that bituminous mix, if you use CNT based aggregate, you will use you will 1 or 2% more, because that aggregate will absorb, just like if we can absorb water, it can absorb bitumen also. Water absorption of zero size aggregates is even more, perhaps because more amount of brick pieces present in it. This material is having even more brick pieces, so that's why it will be having higher water absorption compared to this. This is the gradation curve of the CND waste aggregate and these three materials, whatever I have shown, the CND waste aggregate, Jira size aggregate, and powder. So this is the powder material, the Jira size aggregate, and the CND waste. They are not. It is not a well graded material. Actually, what happened is that we got the material crushed, CND waste material crushed, and then we have sieved it in the mechanical sieves in that crushing plant itself. So when we have sieved it, passing through some sieve and retained on some sieve. That's what. That's the way we have sieved it. So that's why the material is uniformly graded. Material is single size, you can say almost. Powdered material, of course, the whatever that was less than 4.75, that is called the powdered material. So it is little bit. It's not a very flat, very vertical curve. It's a little bit flatter when compared to the other two curves. Now coming to physical properties of the CND waste. Specific gravity of CND waste aggregate, if it is more than 6.3 mm size, it is around 2.3. If it is less than 6.3 mm size, it is around 2.67. Of course, there are no MORTH limits for specific gravity. Normally, the specific gravity of natural aggregate is around 2.65, 2.67. If it is a very high strength aggregate, it may be having a little bit higher specific gravity. If it is having a more amount of iron also, then its specific gravity will be a little bit more, maybe 2.8, 2.9 also sometimes. But normally aggregates like quartzite, granite, etc., they have a specific gravity around 2.65, 2.67 like that. But this material is having a 2.3 and 2.67 depending upon its size. That is because the 6.3 mm size is having more amount of brick pads. The brick pads are porous. So that's why they bring down the specific gravity. Whereas if you go to the smaller size aggregate, the brick pads get crushed. They become powder. So then the porosity will be lower. So that's why the specific gravity improves. The water absorption, once again, for bigger size aggregate is around 4.5%, which is more than the 2% maximum in the voltage limit. Smaller size aggregate, I already told you, will be absorbing even more water. Then the engineering properties of the CND waste aggregate, 20 to 6.3 mm size, unit weight in loose state and unit weight in compacted state, 12.55 and 16.18 kilonewton per meter cube. There are no voltage limits for that. Sorry. Aggregate crushing value is around 37%, which is done by crushing value strength test, and there is no voltage specification for crushing value as such. Aggregate impact value of this 20 to 6.3 mm size is 33%. And MOT says that 30% should be there for base, and 40% can be up to 40% can be used in sub base. For top layers, of course, bituminous layers are 24, 22 like that they specify. That's a different issue. But now I am talking about the base and sub base layer. Now this 33%, it satisfies the sub base AIB. So that's definitely this material can be easily used in the sub base layer, GSB layer, provided the gradation requirements are also met. I already told you this is a non-plastic material also. So it is non-plastic and having a requisite AIB value. So we should see that it meets the gradation limits. Then we can very easily use it in sub base layer. And since it is having around 33% AIB value, we cannot right away use it in base course. We require a maximum should be around 30%. But of course, this is a particular case study in Delhi from a particular CND dumping yard. We got this material, so that's why we got the 33. Let us say in another CND waste dumping site, concrete is more. brick walls are lesser. So definitely this value will come down. This value will come down. It may come down less than 30 also. Then definitely that kind of a material we can use it in even in base course also, provided it satisfies the gradation. 10% fines value we did for different components. So what is the 10% fines value? 45 kilonewton for CNT waste composite sample, 98 kilonewton for CNT waste sample partially coated with the stone chips, and water pieces it's 24 kilonewton, and brick pads it's 25 kilonewton. What is this 10% fines value? Actually, in aggregate crushing value terms, you take the aggregate passing 4.5 mm, retained at 10 mm, and subject it to a particular load, and then you sieve it on 2.36 mm sieve, and then see how much material has been crushed. But if you reverse that process, because why do we reverse? Because when you do the aggregate crushing value test, which is a crushable material like CND, a crust will be formed on the top, and that crust will protect the aggregates below. So that's why it will not give a correct picture of the strength of the material. And the crust, top crust will protect the aggregates below. So that's why we don't have a more specification for crushing value. So they have a we used to have this 10% fine value test in more days, but now it is no longer there. Now they go by AIV only. But anyway, the 10% fines value means we find out what is the load that is required to crush 10% of the material that is being tested. What is the load that is required? That is so they say that load should be higher than 50 kilograms. So what the load that is required to crush the 10% of material should be higher than 50 kilonewton. So you can see that composite sample, which is having all types of material, the IA sample, it is a little bit less than 50 kilonewton. So it doesn't satisfy the 10% fines value. Whereas the stone chips, that is a RCA material, easily satisfies the 10% fines value. And then soundness is 1.6%, whereas it is the maximum limit is 12% as per IS 383. I told you that soundness either MgSO4 or calcium sulfate, magnesium sulfate or calcium sulfate solutions, saturated solutions are used, and in that we dip our aggregate, take it out, and then dry it, once again dip it like that. So each one is called one cycle. So at least 5 cycles must be there. So dipping should be there for at least 24 hours, then drying like that and all. So this after 5 cycles, if it is a unsound aggregate, it will break. So how much percentage of the aggregate has broken up, that we find out that should not be more than 12% as per the IS 383. So we did the soundness test for this CND waste also, and it is having just 1.6% of the aggregate. So this whatever the stone pieces are there, they were Delhi quartzite. The CND waste was taken from Delhi area only. The stone pieces were Delhi quartzite, and so the brick pads were also okay. So that's why soundness test is satisfied. Then AIV, aggregate impact value test. So very simple. We make the sample by passing 12.5 mm retained on 10 mm and subject it to fixed number of blows using the hammer, and after that we see it at 2.36 and how much percentage is crushed. We find report it as AIV. So normally for this type of porous aggregates, we do wet AIV test. What is that wet AIV? Wet AIV is when we soak it for 3 days. When we soak it for 72 hours, we call it as wet AIV test. When we do the soaking, so that whatever the porous aggregate are there, they become even more weak and they crush. They get crushed. So that's the idea. So we did that wet AIV as well as dry AIV test, and as well as 1 day soaking also for different components like stone chips and brick pads and mortar pieces separately, and you can see that these are the values. Stone chips and stone chips is easily satisfying. Brick pads and mortar pieces a little bit difficult. Of course, so it's a little bit more than 40% for the sub-base, but this will be intermixed with this material in CND. So that's why the overall percentage comes down to 33. Overall percentage, when all these three are intermixed, the overall percentage comes down to 30. Engineering properties of the C&D waste, finer than 6.3 mm size, the bordered material, this one, this one, this one, this one. What are the engineering properties of this one? Modified Proctor compaction test, MDD 19.3 kilonewton per meter cube, OMC is 10.5%. When we did the standard Proctor compaction, it is 17.5 and 12.5%. CBR value, very high CBR value, 74%. So it is a very good material for GSP. Direct shear test, 45 degrees is the phi value. It's a very coarse material. So that's why the phi value is very high. And C is 6 Newton per meter square. Normally C is neglected, that is high. And C&D waste may be having a phi value varying between 38 to 51 degrees. However, a limiting value of 40 degrees may be considered for the angle of internal friction during the embankment design. So if we use this type of material, C&D bordered material for embankment construction, maybe having a very high value, but the code says, IRC code says that the phi value for the design of the embankment, for the design of the side slopes, must be limited to 40 degrees. Okay, it's as a precaution. Liquid limit 31% and it's an outpost. Liquid limit is little bit the brickbats will absorb water. Water pieces are there for water pieces absorb water. So that's why this looks like to be 31%, but it's not a correct value. But some amount of water has been absorbed. So that is also being counted here. The liquid limit will be normally lower value. If we delete that water absorption. Water absorption, as you have seen, water absorption. Water absorption, as you have seen, it's around for that. So LL value will be around 20%. Plasticity index, it's a non-plastic material. It has got a very high permeability, very good permeability. It's a permeable material. So that's why the GSB is mainly used as a drainage layer. So that's why this is a very good material which can be used as a GSB material in place of GSB material. Compaction test on C&D waste powder, finer than 6.3 mm size. So what type of standard Proctor and modified Proctor compaction test will be obtained? So that is here. It is a flat curve, just like similar to sand. It's a flat. If it is a clay type of material, it will be having a very good peak. If it is a sandy type of material, the curve will be flatter. The advantage is that since the curve is flatter, even if you vary the compaction moisture percentage, the resulting MTD will be more. Resulting MTD will be almost similar to almost the same as maximum MTD. So that's the advantage of a flat curve. Properties of the aggregates from Haryana PWD, and they tested RCA. So whatever these properties I have given here, this is all for RA. It's all for RA. So for RA. Wherever I tested RCA, that also I have indicated. But this one is exclusively for RCA. They took that they were demolishing some structures, so from that they have calculated aggregate impact value around 30%. They have given the natural mineral aggregate properties also. And crushing value around 35%. Los Angeles operation value around 35%. Los Angeles operation value around gravity 2.45. Bulk density around 15 kilonewton per meter cube. Water absorption once again very high, 4.7%, and it's okay. Like gainers and elongation index are okay. This is another source of C&D waste properties. This is from NCB, National Council for Building Materials, Balampur, which is near Delhi. Physical and engineering properties of RCA. Here also recycled concrete aggregate. So that which was derived from culvert and that which was derived from demolishing building concrete. So they have two different sets of values. Let us see this culvert portion. Specific gravity once again lower. Water absorption higher. But normally we see that for natural mineral aggregate, specific gravity lower, water absorption higher means we will be very much apprehensive for using such aggregate. We see that aggregate may be unsold, that may be having a lower strength, so we don't use that. But that is not the case with C&D waste. Its specific gravity may be lower, its water absorption may be higher, but it will be fulfilling the strength properties, it will be fulfilling the soundness properties of the property requirement for the aggregates. Aggregate crushing value around 36%, impact value around 35%, loss energy absorption around 51%, soundness once again okay, 44.1%, including the sodium sulfate. It's sodium sulfate and magnesium sulfate, sorry, not calcium. Sodium sulfate and magnesium, so Na2SO4 and FgSO4. I stand correct. So this 4.1% is lesser than whatever the MORH has specified 12% balance. Whether you use Na2SO4 or MgSO4, the 12% is the same. Elongation index and flakiness index well within the limits. Demolished building concrete, aggregate impact value around 32%, specific gravity around 2.19, water absorption around 6.9%. So water absorption will always be more and specific gravity will be less. Properties of powdered C&D waste, specific gravity 0.12, water absorption 8%, material finer than 75 microns is not very high. So this is also very another important property. So because material finer than 75 micron is not very high, that's why the permeability of this material will be very good. Permeability of this material will be very good. So that is why this material can be easily used in GSP. Physical and engineering properties of RCA as reported by Dr. Lakshmi Parmeswaran. Water absorption around up to 7%. Bulk density around 11.5 to 14.4 kilometer per meter cube. Specific gravity around 2.32 to 2.56. Aggregate crushing value about 18 to 36%. Aggregate impact value around 10% to 38%. So this shows how heterogeneous the material is. You can see the AAV value very low, 10% AAV value. That means it's as good as a very high strength aggregate, stone aggregate, like very good quality, unweathered quartzite rock, granite rock, or a basaltic rock. The basalt, of course, is a very strong stones. Basalt is mainly it is available in Western India, like Maharashtra, Gujarat, etc., and it's black in color. It will be having a very high, high strength means a very low AIV value, around 9%, 10% will be the AIV value for the basalt. But of course, here, since the RCA will be a heterogeneous material and RCA will be having a coating of this water also, its strength value will come down because it will absorb water. Now, how much coating of water is there? That is also very important. So, coating of mortar is there. That is also very important. The mortar coating is very high. AAV will come down. Mortar coating is lesser. AAV will increase. Now, coming to what the IRC guidelines and IS guidelines says with regard to guidelines and construction methods using C&D waste in embankment, GSP, wound surface and base courses, and cement concrete pavement. So I have taken from these guidelines, M1 is MORT specification for road and bridge works, 20 revised fifth revision and published in 2013. MORT specification for rural roads with first revision, which was published in 2014. And this is IRC 121. That's what I was talking about. Guidelines for use of construction and demolition waste in road sector. IRC 121. This was published in the year 2017. Okay. Then IS 383 also it was revised, and that was revised and published in the year 2016. IS 383 is coarse and fine aggregate for concrete. So all these specifications have provision for using C&D waste. MORTH specification, MORD specification, IRC 121 as well as IS 383, they have provision for using C&D waste in the road sector in different ways. First of all, what they say regarding the processing of C&D waste? This is from IRC 121. C&D waste to be collected separately, no mixing. That means whatever the I told you many times that the soil particles, soil material should not be mixed with the building chunks. Processing of C&D waste comprises of crushing and grading, crushing and sieving, required for obtained desired aggregate grading. Workers to have safety gears to safeguard against sharp-edged glass, ceramic, metal pieces. Okay. Crushing to convert big size chunks to desired gradation, resizing, and sieving in mechanical sieves to obtain the required gradation. Okay. Manual crushing for small jobs only. Intermixing of particles of different gradations if needed, because the GSB has a specified gradation, and whatever the material C&D waste we have crushed, it may not meet it. Then we may need to add some additional aggregate or additional C&D or additional GSB, additional Muram, maybe one of that. So to bring it to the desired gradation. So that is called mechanical stabilization. Intermixing of particles, intermixing particles of different gradation, that is called mechanical stabilization. So when we process this C&D waste, all these steps are involved. We have to crush it, the big chunks into the desired sizes, and then of course sieve it, and then so that we obtain uniform sizes, and then remix it. We can crush it and use it as well without remixing, without separating and remixing. But the crushing process should be so well controlled that the requisite gradation is obtained. That will be difficult, very difficult. So that's why what you normally do, they crush it, afterwards they sieve it and separate it out, and then after separation they take out the required quantities, 1/3 of this, 1/3 of that, and 1/3 of the other in 3 different sizes, and mix it. 1/3 or 20%, 40%, and another 40%, like that, whatever the requisite percentage is required. Now moving to embankment construction, what does the IRC code says regarding embankment construction using C&D waste? C&D waste fulfills the MORTH and MORD specifications with regard to density and plasticity of the fill material. Both the density as well as plasticity. This C&D waste I already told you is a non-plastic material. So plasticity properties you need not worry. The cold limit is also a little bit higher, but well within the whatever the specified limits are there, either 50% or 70%, whatever the LL limits are there. The C&D waste to be crushed to a size less than 75 mm size particles and used in the core of the embankment. I'll show you some drawing that will be, then it will become clear. But whatever the crushing process is there, that should ensure that the maximum size of the particle is less than 75 mm. CND waste is non-plastic, prone for erosion, may not support vegetation growth. So how do we deal with this? So that is overcome by providing about 0.5 to 2 meter thickness is provided on the side slope and as well as on the top also, depending upon the embankment height. The embankment height is lower, 0.5 meter will suffice. 1 meter or 1.5 meter height of the embankment, 0.5 meter will suffice. If it is more, 3 meter, 4 meter, 5 meter, or even more higher height of the embankment, we provide a thicker earth cover. The reason is same, reason is simple. Higher the embankment, more will be the runoff water. So more the runoff water, more will be the chances of erosion. So that's why we provide a thicker cover. But low embankment height is lesser means runoff quantity will also be lower. So that's why the and runoff velocity will also be lower. Both the quantity of runoff are important. So velocity is also lesser. So that's why thinner cover will be sufficient. Design and stability analysis similar to the earthen embankment. Pi value to be limited to 40 degrees. So design and stability, there is a IRC code for designing of embankment, embankment, that's IRC 75. So using that same IRC 75, you can design this CND based embankment also. But we must see that the limiting pi value should be less than 40 degrees. Should be limited to 40 degrees. Please mute कर दीजिए सुनील कुमार जी please mute कर दीजिए. So this pi value I already told you that it can be very high. That high pi value is not used in the design. Normally the embankment design we do it by using a software. Nowadays we don't do manual methods. We use a software. Geo4, Geo5 like that. So many softwares are there. So in that software, whatever the pi value you give as an input, it should be limited to 40 degrees, even though your experimental pi value may be higher. That is because the reason is that non-plastic material. So that's why we use a vibratory rollers. Nowadays, of course, many types of even the pad foot roller also comes as a vibratory roller. Previously we were used to the notion that the pad roller is useful for compacting the clay soil because it is having kind of a kneading action and it compacts the clay soil very well. But now pad foot roller comes with vibration also. So 50-ton vibratory pad foot rollers are there. They are used in for compacting this FDR, full depth reclamation pavement. So such type of 20-ton pad foot vibratory roller that will be very good, very useful even for compacting this CND waste embankment also. Actually, for compacting the CND waste in the municipal MSW compactors are also there. They are also they are a traveler type compactor. So this type of very heavy 20-ton rollers, vibratory is preferable. So that they can compact the CND waste in an effective manner. What are the different steps involved in this embankment construction using CND? Clearing and grubbing existing ground and before the embankment construction. C&D waste material to be tipped, spread and leveled to the required dimensions, earth cover to be laid same time, and the water to be sprinkled, mixed using a disc harrow. Whatever the cover soil is there, and whatever the core of the embankment is that we are constructing using C&D waste, both should be laid simultaneously and compacted simultaneously. The rolling, of course, it will start from the ends, move towards the center. That's the normal process. And towards the center, the C&D waste will be there. Outer edges, the earth cover will be there. And what should be the thickness of the earth cover? 0.5 to 2 meter, depending upon our design, depending upon the height of the embankment. Water content to be OMC plus 2, OMC minus 2%. Due to porous nature, slightly higher water may be required. Yeah, because the brickbats may absorb water. Compaction to be done using vibratory roller, layer thickness to be less than 250 mm. Rural road embankment height less than 1.5 meter can be compacted by using static roller also, but we have to use a lower lift thickness. The subgrade of good earth over the embankment is required. Subgrade thickness 50 centimeter for a highway work and 30 centimeter for a rural road work. That will be same. So, and subgrade is to be constructed using a good earth. So this is the cross section or a schematic view of a C&D waste embankment. I told you C&D waste will be used in the core of the embankment, center of the embankment, and it will be protected by good earth cover and that in the sides as well as in the top. And this earth cover, I told you, 0.5 to 2 meter thickness depending upon the height of the embankment. And if the height of the embankment is more, we can go for intermediate soil layers also. So this cross section of the embankment and is very much similar to whatever the embankment you would have seen when Dr. Vasant presented fly ash embankment. Fly ash is also similar material. It is also non-cohesive and non-plastic. So here also the material is non-cohesive, non-plastic. So we use a similar type of design for the embankment construction. Core of the embankment or center of the embankment constructed by using C&D waste, earth cover, and in the top also earth cover. Now, GSP construction using RCA. Now, how do we construct GSP? We follow the MORT specification clause 405. It says that crushed cement concrete subbase can be adopted. So this particular clause 405 is for using the C&D waste alone, using the C&D waste alone as a GSP material. There is a one particular clause in the MORT specification, that is the clause 405. And it is with regard to using the crushed concrete, cement concrete subbase. So we cannot, as per this clause, we cannot use this RA, and it restricts the use of RCA. But if we follow the clause 401, clause 401 for the GSP material in the MORT, in that 401, we can use the RA also. But let us first see this 405 and what is it says. The crushed concrete gradation must be as per WBM G2 or G3 grading compacted to layer thickness of compacted layer thickness to be 75 mm. Each layer should be 75 mm. So let us say we need a GSP layer thickness of 200 mm. Then we can go for 75, 75, 50 like that, or 75, 75, 2 layers of this RCA, then another 50 centimeter thick muram layer like that and all. So depending upon whatever is materials are available. So crushed cement concrete grading for G2 and G3, WBM G2 and G3 I have given it here. Okay. The important point is that whatever the material is there, crushed concrete is there, the concrete should be crushed to adhere to fulfill this gradation limits either for WBM G2 or WBM G3. Okay, and each layer should be 75. Compacted layer should be 75 mm. RA usage in GSB. This I told you we have to follow 401. Clause number 401. This is 405. RA when we want clause number 401. This is 405. RA when we want not be mixed with the fine soil suitably crushing the CND waste, adopting the mechanical stabilization if required. Intermixing the muram, sand and gravel can be tried. It is having a good drainage, high CBR value. It's non-plastic material. AIB and CBR and plastic requirements to be as per MORTH or MORT specification. Both MORD and MORT specifications permit use of RA in GSB layer, provided the aggregate impact value is less than 40%. The gradation limits are met, and it is non-plastic. This material is of course definitely non-plastic, unless we purposefully. Unfortunately, some clay material is intermixed with this CND waste. It will not be having any plastics. It will be non-plastic, and its AIB value will be also be usually lesser than 40%. 40% is for MORT specification. If you follow the MORD rural road specification, AIB limit is 50% for the sub-base layer and 40% for the base course layer. So CND waste in the base course also definitely you can use in as per the MORD specification for rural road. And GSB mixed design, how do we do that? This, of course, I have shown using a trial and error method using Excel sheet. So 3 materials are there: Jira, aggregate, and this powder material, and how much of each if you mix it, and if you see the GSB gradation grading 6 as per the MORTH, and which one is fulfilling this requirement, this is one way. Another way is that there is a provision of a using this Excel also. You can calculate it. Of course, I don't have that much time now to show you that Excel sheet. Maybe I will email that Excel sheet. You can from that you can I'll send it to IIH. They can share with you how using the Excel how to do the GSB design, and of course a little bit out of this GSB mixed design this thing. But that Excel sheet I'll send to IIH. They will share with you. Properties of concrete mix. Properties of this GSB mix made using this CND waste. We tested in CRRI, and what was the MDT value and CPR value. When we have intermixed these 3 materials, of course, it is having a very good property when compared to CND waste powder. I just for comparison purpose I put it here. So it was CND waste powder itself was having 74% CBR. So when it was intermixed with some aggregate also, it is having 115% CBR. It's very, very high. Normally, this WBM or WMM is considered to be having a CBR value of 100%. Okay, and this whatever the material, naturally available material is having a CBR value of more than 80%. That can be used in base course layer. MORD specification states like that. A mixture of soil and aggregate, if it is having a CBR more than 80%, we can use it in base course soil aggregate mix. So this CND waste also is having a very high CBR value. So as a GSB, definitely you can use it, and even as a base course also you can use it in rural. Then properties of the cement stabilized CND waste. Cement or cement plus fly ash can be used for stabilizing the crushed CND waste stabilization. As per the MORTH or MORD specification can be done, and it is as per IRC SP 89. We follow that. SP 89 code for stabilization. crushed C&D waste should fulfill the requirements of cement stabilized material as per specification. Mixed design as per IS ASP 89. Rural roads cement stabilized subbase to have 7-day UCS of 1.7 MPa, base course to have 3 MPa strength. As per the IS ASP 89, 7-day UCS of 1.5 to 12 MPa for different for higher category roads. SP 89 says some base layer must have a minimum strength of 1.5 MPa. For rural roads, we say we have 1.7 MPa. So definitely 1.7 MPa we can take it, 7 days stabilized material strength. For base course, normally we take for rural roads, so it is specified as 3 MPa strength, 7 days. For higher category roads, whatever the material strength is there, the stabilized material strength will normally it should not be below 4.5 MPa. That's what we usually say. So 4.5 MPa to 12 MPa. 12 MPa is a little bit higher. Actually, stabilized. If we have a very high strength stabilized base, also the cracks will be. That's the problem. If the lower strength material is there, there will be numerous cracks, but the cracks will be smaller. But if the higher strength is there, the cracks will be lesser, but the cracks will be wider. That's the problem. So normally we don't prefer very high strength base course material. So 4.5 MPa is very much optimum for highway works, and 4.5 to 6 MPa is optimum. And for rural road, 3 MPa is that's what as per the MORT specification. So same manner, this C&D waste also we can stabilize it by using some cement, and if it attains 1.7 MPa, 3 MPa, we can use it in the surface or base course of rural roads. If it attains about 4.5 MPa, 6 MPa, we can use it even for highways also as a base course there. So we did some studies. These are the results of the 3%, 5 and 7% cement addition. Okay, let's see the Proctor test. And what are the strength values? Unconfined compressive strength values. So we require around this is 1.9 MPa. So we require around 6% cement for the subbase layer, and base course, of course, it's not very high. This is, of course, this is when we use C&D waste powder. If we add the C&D waste aggregate also, these values will get higher. These values will get higher. This is totally for the powder type of material items. Now coming to IS, what IS 383 says with regard to percentage replacement of natural mineral aggregate. NMM is natural mineral aggregate. It says that depends on the type of your concrete, whether you are using PCC, plain cement concrete, or RCC, or lean concrete, less than M15 grade. Lean concrete, you use it for this base course in below the PQs. So C&D waste type RCA, recycled concrete aggregate, it can be 25% maximum in PCC and 20% maximum in 25. And in lean concrete, we can use 100%. REA is not advocated for either PCC or RCC, but in lean concrete, we can use it. As a fine aggregate, RCA percentage is 25, 20, and 100%. So we can use C&D waste either as a fine aggregate or a coarse aggregate in this in cement concrete works, but Indian ports restrict the usage below M25 grade. This is somewhat very much you may say that compared to the foreign ports, compared to the British ports, European ports, and the foreign ports, very much conservative, you can say. But till now, IS 383, it had no provision for using the C&D waste. Only in the year 2016, they have revised it and they have brought it. And so that's why this is the first attempt. So that's why it's on the conservative side. Okay. Desirable, and some more points they have given. desirable to source RCA from the redevelopment sites for use in same site in any given structure. Only one type of manufactured coarse aggregate and one type of manufactured fine aggregate shall be used. RA can be used as a coarse aggregate and RCA can be used as both coarse and fine aggregate. So this is also very important point. This is also very important point. Only the RCA can be used as a fine aggregate, not the RA. Aggregate conforming to IS 383 can be used in the DQC, PLC, and paver blocks and curb stones. What does the IRC 121 says? It says we can use it in so many ways, PQC, DLC as well as. For PQC M30 and below, RCA size could be like that, and we can go up to 30% replacement, and RA usage can be 20 to 30%. And natural sand is to be used as a fine aggregate. So these two codes, the IRC 121 and IS 383, are little bit not totally in agreement because they were published in different times by different agencies. They are not totally in agreement. But anyway, if you want to construct the road structure, we can follow the IRC code and for our cement concrete works. The IRC code says that don't use this either RCA or RA for as a natural replacement for sand, but use it for a replacement of aggregate. And there the replacement percentage is also 30%. Here it is 20%. So, but they allow this fine also, so that's fine. That's fine. But here the fine aggregate is not allowed, so they are allowing up to 30%. But finally, whether you go for 20%, whether you go for 25%, whether you go for 30%, or whether you go for 10%. Finally, all will depend upon your mix design and whether you are getting your requisite compressive strength. That is the important. That's the so every time, whenever you plan your C&D waste usage, you must do proper mix design. How much water is required, how much quantity of cement is required, how much of natural mineral aggregate required, and how much of replacement may be made using the C&D waste. All these should be properly investigated, and then only you can go ahead with your construction. NMA replacement by RCA and RA not advocated for PQC, which which requires M40 and above grade for highway works. So M40 is not advocated even in the IS 383 also. So here also they say that for the time being, let us not use it in PQC. Let us use it in DLC. Let us use it in this paver blocks, curb stone. And this PQC, of course, it is for rural roads. Curb stones and paver blocks for footpath and cycle tracks, parking areas, rural roads with less than 200 vehicles per day. So RCA replacement can be up to 100% also. Up to 30% of NMA can be replacement by RCA in DLC. Powdered C&D waste can replace 20% to 25% of natural sand in DLC and RCCP. This can be in addition to RCA and RA usage. Combined gradation of NMA and RCA should meet specified gradation. Mix design to be carried out as per IRC for optimizing the quantities of constituents. So this is the I already told you. Mixing ingredients as per the two-stage mixing. That is also another important point. So what is the two-stage mixing? NMA and fine aggregates and RA and RCA are mixed for 60 seconds. Half of the required water is added, mixed for 60 seconds in the stage 1. Then the cement is added and mixed for 30 seconds. The remaining water is then added and mixed for 120 seconds as stage 2. So this stage-wise mixing of aggregates, putting water, that is the two-stage mixing. This is done. The importance of two-stage mixing is that this whatever the RA or RCA material is there, you will absorb water. So that's why you first mix it with the natural aggregate and then put some water, then mix it. Then once again, then you add a cement and then the remaining water and mix it. So that's the two-stage mixing. RA and RCA manufactured RA and RCA produced as concrete as in structural concrete. Then generally for PSC or the bridge structure, the IRC code says that please don't use the CND based aggregate. So we did some studies with CND based replacement for DLC, dry-lean concrete in CRRI, and how much strength we achieved after 28 days, 7 days and 28 days, that's given there. And even with 0% and with 20, 40, say 60% replacement, you can see that just here also he has replaced even up to 100% also, and compressors. These are all for high strength concrete. You can see that the flexible and they are quite okay, quite good. The basic the point that I want to make is that do the right type of mixed design. Do the right type of mixed design, even with CND based and waste aggregate replacement also, you can get higher strength. Quality control, quality acceptance test, RERCA should be free from deleterious material, whole organic and this thing, free from chemicals that are detrimental to concrete. Quality checks, frequency and type of test for the embankment and pavement construction using CND waste shall be as per the above teaching. Whatever the soil and other natural material quality control tests are there, same type of tests are to be done. Density test, warm water, moisture content test, etc. This BIS specification shall be applicable. Application of M voltage and M voltage specification depending upon the category of the road. If you are constructing a rural road, we do the quality control test as per the M voltage specification. If you are constructing a highway, we do it as per M voltage. So some case studies. So this is a CND based processing plant set up in Delhi at Buradi. It is a PPP project, public-private partnership. And this is a crushing unit there. And that was a mobile unit, and initially they had set up, then they set up the entire plant and how that plant looks like and all. You can see that. So this is a they are preparing the from concrete blocks. They are preparing the RCA material, and when totally RA is getting crushed, so they are making some manufactured sand also, because they are washing that crushed material and manufacturing the sand also they are making, and this type of building blocks also, and the curved stones and paver blocks also they are making. These are the curved stones they are made using the RCA replacement, and they made a cement concrete road also using this just the approach road to that plant also, and very small. Very heavy trucks carrying the CND waste. They were playing on the on this road, but even then also you can see it is performing quite well. And they constructed the MCD, the Municipal Corporation of Delhi. They wanted to widen the road nearby also in Buradi area, and they did the widening by using the CND waste. So for the GSP layer, they used CND waste, and for the base course, they used this cement stabilized CND waste, and of course there was one crack relief layer of G3. Then above that, the DBM and BC layer, they were it was same was there, and these are some photographs of that construction. Cement stabilization for the base course layer. So they have placed the cement bags, opened it, spread it, and they are mixing water. Then after compaction, after this curing, you can see the stabilized base course there. It's having a very good strength. In Karnataka also, KRRDA, Karnataka Rural Road Development Agency, they near to Bangalore city, some one rural road they constructed using CND waste, using CND waste from Bangalore. And what was the conventional specification and the using CND waste in the sub-base layer and as well as base layer. So they constructed three different stretches. Total length was 1 kilometer, and the three different stretches were there. You can see the photographs of that rural road. It was for a very small habitation area. It was under the Mukhyamantri Gram Sadak Yojana, not the Pradhan Mantri Gram Sadak Yojana, Mukhyamantri Gram Sadak Yojana. Around 450 was the, I don't know, around less than 100 or 150 was the population of the small hamlet, and that they connected by this road. And we did Bengaluru beam studies also, how much deflection is there, etc. And it was all okay, comparatively okay. Then this DDA, Delhi Development Authority, they constructed another 4-lane road in West Delhi. Near the place is called Bakkarwala. Connecting Bakkarwala to this NH10. So there they use CND waste in a large quantity because the ground was slushy ground was there. So they required some ground improvement measure. Whatever the slush was there, slushy soil or the muck was there, that was removed and that was replaced by this CND waste. And because otherwise that slush and muck was detrimental for this 4-lane road construction. So that's why it was removed and it was replaced by this crushed CND waste. So these are some photographs doing some field testing, SPT test and plate load test. This is how that area was like that, slushy area, very high water table. And this is the muck or slush, you can see it has been removed and then it was replaced with CND waste. This is the drawing. After removing that muck, it is being replaced by CND waste and compacted. And above that, they have constructed this road, and this is the finished view. And after this base force layer, so you can see this road is performing very well. So they used this CND waste as a fill material or the replacement material for ground improvement. So conclusions, CND waste has marginally lower strength value, may be used as a component in GSP layer. Cement stabilized CND waste can be used to replace part of the subbase or the base course depending upon the compressive strength. We do agree that this material has a lower strength, so that's why we can use it in GSP layer, we can use it in cement stabilized layer. It can be used for partial replacement of conventional stone aggregates. Cement concrete, we can use it 12 to 18% decrease in strength. Notice for 50 to 60% replacement, so that we can restrict the replacement percentage in cement concrete to whatever the codes says, either IS can be used for embankment construction after crushing. Side slopes to be protected using Buda, GSP layer and stabilized base and base, but not advocated for bituminous layer. We cannot use CND waste in bituminous layer because it will absorb more bitumen. Instead of 5.5% optimum bitumen content, it may increase to 6.5%. So that will be uneconomic. And another is that the coating of that bitumen also will not be proper. Some aggregate may not be coated properly all over. So that's another. So these are some important points with regard to CND waste I wanted to tell you. So now I think we have run out of time exactly. So let me conclude here. If you have any doubts, you can ask. So these were the important issues which I wanted to discuss with regard to this using CND waste, and there are no comments also in the comment box. So any participants, if you want to ask any Any participants, if you want to ask, also now, right now, you can ask. Otherwise, we can come.
Hello. You have mentioned about that generally we can use in the rural road only. Can we use it, sir, in the urban area also by increasing the thickness of the GSB? Sir,
We
you
can
got my point.
definitely,
Yeah.
yes, we can definitely use it in urban areas also. I showed you a case study where Municipal Corporation of Delhi, they used it for widening of that city road only. Of course, in urban area also, all the roads will not be subjected to high traffic. In the colony roads, the traffic density will be very much lower. Only in the trunk routes, main urban arteries, the traffic will be very high. So in the majority of the roads will be colony roads. So in the colony roads, definitely we can use this CND waste material. Even for highway works also, even for arterial roads also, we can use CND waste. But where we can use CND waste? We can use CND waste in the embankment construction. We can use CND waste in the GSP layer construction in for high traffic roads. But in high traffic roads, I don't advocate using it in base course layer or in, of course, bituminous totally ruled out. Don't use it even for rural roads also. But for the base course, we have to be careful where to use. That's the point. Any other question?
Thank you, sir.
Thank you. So if there are no more questions, so we can conclude this session, IAG.
जी सर.
If the participants have any questions or have any doubts, please ask your questions or I again requested to the participant that if they have any doubts, please clear your doubt. Otherwise, we will conclude this session.
Yeah,
Sir,
actually, if you
I
can,
think that there is no questions from the participant side. So now we can conclude this session. Sir, thank you very much for sharing your presentation
thank you,
as
thank
well
you.
as your experience on the subject. I think that the participant will get the benefited from your lecture, sir. So thank you very much, sir. So now, from these words, we conclude this session. Another thing is that all the participants are requested to join by 11:45 today. Also, we are also conducting next session that earlier was proposed on Saturday. So for that also, we have already shared the Webex link in the WhatsApp group also. So all the participants are requested to join by only that link. Actually, that link is only applicable. This link is not applicable for the afternoon. This link is applicable also for tomorrow morning lecture. Okay, now from these words, I conclude this session. Thank you very much.
Thank you, Ji. I will be sharing my presentation with the IAH. They will be share the presentation with all the participants also. And if you have any doubts later on also, you can contact me through the email. You're most welcome. Thank you and namaste.
Okay, namaste.